Good day, everyone. I am S. Maria Anthony, Assistant Professor of EC Department at KIT Kalaignar Karnataka Institute of Technology. Today's video lecture is about Introduction to Basic Applications of Operational Amplifier. Operational amplifier is nothing but an analog circuit block that will take a differential input and produce a single-ended output voltage. It is an integrated circuit that uses an external voltage to amplify the input through a very high gain. It is used in numerous consumer, industrial, and scientific electronic applications because of its ability to adapt to different roles while maintaining the reliability and precision, making them indispensable in a multitude of fields. Given below is the pin diagram of a commonly used IC 741. There are 8 pins in this. The first pin is offset null, second pin is inverting input, third pin is non-inverting input, fourth pin is negative supply, fifth pin is offset null, sixth pin is output, seventh pin is positive voltage, and eighth pin is no connection. This is the symbol for the operational amplifier. It is shown below. It has commonly used 5 terminals displayed here. They are your inverting input terminal, non-inverting input terminal, positive power supply, negative power supply, and output. The internal schematic diagram of IC 741 is shown below. It is constructed using numerous transistors, resistors, few diodes, and capacitor. The basic application using an operational amplifier is going to be the inverting amplifier. A circuit diagram and the operation is discussed here. The operational amplifier is connected as a inverting amplifier here. The input signal is applied to the inverting input terminal using a series input resistor. As you can see here, input resistance Ra is given here, and the non-inverting terminal is grounded. The output is feedback through a feedback resistance Rf to the same input terminal. It has an infinite input impedance, which implies a zero current at the inverting input. Since there is no current at the inverting input terminal, the current through the input resistance Ri and the current through Rf are equal. So this circuit diagram clearly shows here the input current In and the feedback current If going through the resistance Ri and Rf respectively. The voltage across the feedback resistance will be equal to minus Vout because of the virtual ground, and hence we can equate the feedback current If as minus Vout divided by Rf. Since If is equal to the input voltage In, we shall have the equations as minus Vout divided by Rf equal to Vin divided by Ri. Rearranging these terms, we'll be able to see Vout by Vin will be equal to minus Rf by Ri. Therefore, the overall gain for this circuit is ACL is equal to minus Rf by Ri, where Rf is nothing but the feedback resistance and Ri is the input resistance. The negative sign will indicate the output relation and the input relation of the signals. That is, the output and input will be 180-degree phase shift. Next application for an operational amplifier is a non-inverting amplifier. It is a closed loop configuration as shown in the circuit diagram. The input signal will be applied to the non-inverting input terminal, and the output is feedback to the inverting input terminal through a feedback resistance Rf, and resistors Ri and Rf form a voltage divider circuit which will reduce the output voltage, and it connects the reduced feedback voltage to the inverting input. The overall output voltage for this circuit will be equal to V naught is equal to 1 plus Rf by R1 into Vi. Voltage follower is another application of a operational amplifier. It is a special case of non-inverting amplifier where all of the output voltage is fed back to the inverting input terminal by a short circuited connection as shown in the circuit diagram. For a voltage follower case, the closed loop voltage gain for the voltage follower is equal to 1. The output voltage for the voltage follower will be equal to the same as the input voltage. V naught is equal to V in. Next application will be op amp summing amplifier. The summing amplifier is a circuit in which the output is summation of all inputs amplified by the gain of the circuit. If equal value resistors are used, then the output will be equal to the algebraic sum of the inputs. It can be configured either to be a inverting summer or a non-inverting summer circuit. The output shall be given as Vout is equal to minus Rf by R1 into V1 plus Rf by R2 V2 plus Rf by R3 V3. As you can see here in the circuit, there are n number of inputs given through n number of resistors to the inverting terminal, and there is a feedback resistance. So this is a inverting summer. Next application is a differential amplifier using op amp. The differential amplifier is nothing but a circuit in which the output will be difference of the inputs. Differential amplifiers, they amplify the difference between the two voltages, making this type of operational amplifier circuit to be a subtractor. The output voltage for this circuit will be equal to Rf divided by R1 V2 minus V1, where V1 and V2 are the two different input voltages and Rf and R1 is the feedback resistance and the input resistance. Thank you everyone for your patient listening.